my hopes and desires for the science that was going to come out of Skylab, I thought, well, it's cooked.
On such a timeless flight.
In 1973, I was commander of the second Skylab mission, and Jack Lousma was the best EVA guy that I've ever met. And I said, if we send Jack out there and let him work on that thing, he'll find a way. Lo and behold, he goes out there and fools around with it a while trying to get these connectors undone, and finally gets them undone and puts it all together, and it worked great.
And he went on to a brilliant scientific discovery, which had to do with coronal mass ejections. And for the first time, we were able to see these, where big chunks of the corona blow off.
It's day after day of hard work. And even though you have a nice view out the window, that doesn't kind of pay you back for the constant effort that you have to put out to be productive in space. It's a tough job, and only dedicated humans can do this sort of thing.
It operated for about 9 months, which was much longer than had been anticipated. And at that time, we understood some things that we'd never understood before, and it gave us some forward momentum in the science that it continues right now till today.
Let me call to express my very great admiration for your hard work, your total dedication in preparing for this first joint flight.
The day is not far off when space missions made possible
by this first joint effort will be more or less commonplace.
One of the huge surprises of the mid-20th century came with one of the Mariner spacecraft. The Mariner spacecraft started towards Venus, and they found that the sun's magnetic field, far away from the Earth, was about as strong as the Earth's magnetic field. Now, I had been taught, and everybody else had been, that the sun's magnetic field would be negligible. And so it presented us with a tremendous confrontation of how could that be so?
Venus and Mars are all right tonight. Is there life on Mars?
The one planet that was most intriguing to humans, human scientists, was Mars. Mercury was closer, but it was very inhospitable. Venus was the nearest one to us, but it was very inhospitable because the atmosphere was toxic and hot.
Mars showed seasonal variations that suggested something was alive. And I think that was the basis for creating Viking, to see if there was life on Mars. When we got down and found out how dry and arid and barren the place really was, came as a bit of a surprise.
I've been through the desert on a horse with no name. Felt good to be out of the rain.
We had hoped to find microscopic life. The thing that happened that kind of left us in a quandary was the 3 experiments that were directly life detecting. Did it breathe? Did it eat? Did it do photosynthesis? All said there's something here. And when you tried to find the dead bodies, you couldn't. So that kind of left us in the position why the jury is still out.
In the end, we ended up with 2 successful landings on the surface and 2 very successful orbiters that exceeded their lifetime by many, many months. So obviously, we were all elated, and all you could say, we did it, we did it.
When we flew by Neptune, people were standing in line at night at planetariums in order to be able to see the images coming in from Voyager, because they weren't on the web in those days. There was no web. You had to go somewhere in the middle of the night to see it. It became a worldwide event when Voyager was flying by these worlds, and I had no idea that it would have that kind of an impact. And of course, that in the long run is the most important thing Voyager's done, is show how much there is, the new frontiers of space.
You're a shining star, no matter who you are, shine bright to see, you truly be.
The 1970s really saw the start and heavy activity in the project aircraft area, which initially focused on STOL aircraft and then moved into the VSTOL arena. So the rotorcraft work got underway very heavily and has continued to today until it is the remaining flight research activity.
There were about 5 of us that came into the Space Systems Division that had been formed to support shuttle development.
Working on mysteries without any clues.
Coming to work was fun to do that kind of thing.
Working on a night move.
That was a little bit unique. It's kind of like having some very expensive toys to play with.
The development of the shuttle. I think that was a magnificent development program. You know, there were an awful lot of people, including some people at Langley, that were very hesitant that the shuttle would be successful. Would all those thousands of thermal tiles underneath protect it? Would it burn up? It turned out to be a tremendous opportunity.
6, 5, 4. We've gone for main engine start. We have. America's first space shuttle, and the shuttle has cleared the tower.
A vehicle that could launch into space as a rocket, put 25 tons of cargo into orbit, and land on a runway like an airplane. Not just once, but over and over again. In the 1980s, NASA would rip this concept from the pages of science fiction and place it squarely on the cutting edge of space travel.
Going up the launch pad, looking up and seeing, this huge, rocket that kind of sounds like an animal. You can kind of hear the gurgling and the hissing, and, it sounds like it's alive.
The few seconds right before liftoff, every time I've done this, has been a little bit of fright about whether I really want to be doing this or not.
10 seconds, we have go from main engine start.
I was really just focusing right on the tasks at hand and trying not to think about, the fact that tons and tons and tons of rocket fuel were about to explode around us.
Liftoff of Shuttle Discovery.
Discovery, roll program.
Roger, roll, Discovery.
Discovery on the proper alignment of the 8.5-minute ride to orbit. Seconds into the flight.
The forces and the sensations are just powerful beyond imagination. They shake you so much that you can hardly see the displays in front of you. Right after the solid rocket boosters are jettisoned at 2 minutes, it's a very smooth ride. The acceleration is very powerful, and you're on your way to orbit with a very different feeling.
As soon as you achieved orbit, the engines cut off. Just instantaneously, you go from being pressed in the seat to hanging in your straps and sort of floating in the cockpit.
The fact that I was going to be the first American woman to go into space carried huge expectations along with it. And of course, it was very important to me that I understood my role really well and that I was really well prepared for the mission, because the last thing that I wanted to do was get into space and make a mistake. So I wanted to be very, very sure that I was able to meet the expectations.